Alright, with these next problems, there's a little bit of a departure from the last video that we looked at when we were finding the inverse of these particular trig ratios. But what we're looking at is we're finding all of the solutions of the following. And all the solutions means is that we have a blank check to operate outside of the standard issue of the inverse sine, inverse tangent, inverse cosine, etc., etc. So let's go ahead and take a look at this first one, how we're going to do this out, and see where this takes us. First thing we want to do is that we want to get all the trigonometric ratio on one side and all the constants on the other. So I'm going to add sine x to both sides, and I'm going to throw the square root of 2 over on this side, and that's going to give me 2 sine of x equals a negative square root of 2. And then, to finish things off, I'm going to divide each side by the square root of 2, and it's going to be sine x equals a negative square root of 2 over 2. Okay. Now, here's the deal, is that we're looking for the angle x. When we take the sine of it, it's going to give us a negative square root of 2 over 2. So we know that it can't exist here because sine is positive. We know it can't exist here because sine is positive. It has to exist here or here. So, therefore, we have to think about what angle is going to give us a sine. When we take the sine of it, it's going to give us square root of 2 over 2. And it's going to be over here, because that'll be negative, and it'll be over here. And again, these are based on our reference angles and whatnot we'll practice in class. So I know, and I'm going to color code these different, that this angle right here is going to give us a negative square root of 2 over 2 when we take the sine of it, and also this angle when we take the inverse sine of it, it's going to give us a negative square root 2 over 2. So let's look at the blue angle first. We know that the first time that it hits a negative square root of 2 over 2 is going to be 5 pi over 4, because that's what that angle is. Now we know that it's going to hit 5 pi over 4 again when we go around here and we go 2 pi radians around. And every 2 pi radians around, we go ahead and hit that particular angle. So we put 2 pi n, where n is an integer, to go ahead and make up for all the angles. So we can find them all just based on this particular little algorithm that we wrote for finding x. For the purple values, is that we know that x is going to be 7 pi over 4, and that is going to go ahead and hit every time that we go around here 2 pi. So 7 pi over 4 plus 2 pi, which is the turnaround in radians of a, just basically one turnaround from there, where n is an integer. So this would be the entire answer set for that particular equation, because again, we can find any angular measure in radians that satisfies that equation based on these two algorithms that we went ahead and built, even though they're outside of the range of arcsine. So that's how you do that, and thank you for watching.